Hello, and welcome to Pulumi TV. This is Modern Infrastructure, and again, we are doing this live. So please feel free to be involved. If you have any questions or you want me to dive into anything in a little bit more detail, then please drop something into the comments, and I will do my best to tackle them as we go. If you haven't seen Modern Infrastructure before, my name is David Flanagan, and I am your host. Modern Infrastructure is a show that we do every single week on Pulumi TV, where we try and show you some of the new things that are happening in the Pulumi space, or just new ideas and patterns with things that you can do with Pulumi that you may not be familiar with. Today, we are going to take a look at something that was announced on May the 4th at our Pulumi Up event, which was our Pulumi and CDK Interop. Now, my colleague Lee Briggs and I actually did a session at CDK Day just last week, where we actually showed people how they can, pull in CDK constructs into their Pulumi program and run them all as one, which is a really, really cool pattern because Pulumi really wants to be the tool for universal infrastructure as code. Our interoperability, our interoperability does not end or start with CDK. We support bridging Terraform providers. We support working with many other tools within this space. We have really great Kubernetes support, and we integrate with other GitOps tools as well. So it's really just nice to be able to run a new Pulumi program, pick your language of choice, and be able to consume all of these different other ecosystems and the patterns that these other ecosystems are developing as well, which is what I want to show you today. So I think without further ado, is we'll pop over to my screen share. And this is the article by Lukobin, our CTO, who talks about our CDK support on Pulumi. And he's got a few examples in here. The first one is just using a CDK construct. This one is pulling the CDK lib AWS event target. Also pulls in Lambda. What you'll see here is that it defines a Lambda function, adds a new rule, and then uses the synth. If you've used CDK before, you'll be pretty familiar with this synth command. This is what produces the output of the plan for things that are going to be run. Pulumi can consume that and pull it into the Pulumi resource graph. And then you just run the stack. The only thing special here, and that is that we create a class that extends our Pulumi CDK.stack. And that's it. Once you've done that, you then call the super, and we have this remap cloud control resource. This is kind of omitted in this article. Luke does talk about it, but I want to show you exactly how to do this because from speaking to people adopting Pulumi and using CDK constructs, this has been a bit of an opaque or confusing thing for them. So I'm going to break that all down for you today, and hopefully under 15 minutes. And we have a wave. Hey, Chris, how's it going? Thank you for joining us. So there's more to this article. Luke then goes on to talk about some more stuff here, and eventually we get down to the remap control resource. So what happens here is that the AWS native provider in Pulumi uses the Cloud Control API to generate our native SDK. We don't use CloudFormation whatsoever. We speak directly to the AWS APIs, but we only have, at least in our native provider, knowledge of the resources published via the Cloud Control API, which admittedly is pretty vast, but there are a few things that slip through the cracks. For that, we actually need to map them to resources on our AWS Classic provider, which is the one that bridges the Terraform provider. So you'll see here that a Lambda permission may not be an object on the Cloud Control API or AWS Native, but we can tell it that, when we get something that looks like this, this is how we construct it. And I'll show you how to debug this as well, so don't worry. Luke then goes on to talk about L3 constructs. So these are really cool from the CDK ecosystem. This is where people are producing really nice, fluent APIs that allow you to do a small set of tasks. The one we were looking at today is where you want to deploy a Lambda, stick a CloudFront distribution in front of it, and a REST API proxy via API gateway. Like all of that can almost be one line of code. And there are constructs that make that kind of possible. All right, enough with that. Let's get over to our code. So I'm going to open index, and I'm using the API Gateway Lambda CloudFront API L3 construct. So the top one here is what connects all of the glue and makes our Lambda available kind of publicly. But then we also need to use the Lambda and API gateways directly. Now, this code creates well, this is just the properties and then we create it here. So we'll group this as one, right? But we're creating a Lambda function and we're doing it in line, which means we're just reading this hello.ts. And this is really simple. This is just a handler constant, which is exported, which does a console log.hello world. So we read that and store that as a Lambda inline code. We set the Node.js runtime and we tell it what the export is on the function, and that will deploy our Lambda. The next thing we need to do is define our API gateway properties. Again, I've split this into two, but you could do it in one if you wanted. And we're just saying that our handler is this function. Next, we use the L3 construct from the CDK ecosystem, where we pass in this API gateway, and it does all the magic stuff for us with the proxies and the distributions. We call the synth, and then that's it. Then we have our component, which I've horribly called my component. I am really sorry. But we just say we want a new component. We call it raw code. Now, I could change the interface to this, of course. It may be that I want to pass in my JavaScript here so that this is entirely reusable. And I could do that too if I wanted. Of course, I'd have to make this a map, and then we'd say code, something like that, right? So once you get this working, it's up to you how you construct that API and what you want to make available to your developers or platform teams or anything like that. So this is really cool. But today's focus is on this remap method and the adapter and how do we make that work. So what I'm going to do is come over here and run a Pulumi preview. And this is going to kind of work to a certain point and then it's going to bomb out on us. And the problem here is that yes, there we go, is that we have the resource type AWS native API gateway REST API is not found. So this REST API object is one that is not found in our AWS native provider and isn't mapped by our CDK interopt. So we can fix that. Now, I've already adapter function, so I'll show you in a moment, and it just lives in this adapter directory, much like Luke's examples in the article. Once we have this function, we can modify the call to our super, so our super constructor, and we pass in our remap, like so. If we open this up, all right, we'll do it this way. We have a function here which takes in a whole bunch of elements. Now, this is just the resources that are involved, the properties, the logical ID, other things to identify the resource that we're working with. We can normalize the props so that we can work with them in standard JavaScript notation. And I've got one commented out here for a second. We'll come back to that. But here's the one that we're missing. So what we say here is that we have an AWS API Gateway REST API. Now, what's important here is that this doesn't actually map directly to the error message that we got, which is a point of confusion for people that are trying to work out how to build these adapters. Now, it's close, but you need to be able to work out how do I know what that value is. And I'll cover that in a second. Once we know what that value is, we just use the AWS Classic provider. So AWS here resolves to our AWS not native provider. Pass in the logical ID, and then we expand the properties. Now, depending on what the properties are, you may get away with just doing props. But if there are nested values and arrays that need to be condensed into single values, like this one here, you will have to kind of deconstruct them. And the debugging approach to finding this identifier and the property values is the same. Super hacky, but console.log. From here, we can say we found a type for, and the properties of this type are X. And this is going to give you everything that you need to know. Now, there's one more catch to doing this. When we run Pulumi preview, You probably want to enable log flow and logs to standard error. This just means you're going to see everything from the providers and no error messages are going to be left unturned. So let's run this. I'll have some coffee just now. Sweet. Few resources here. It may be that I want to filter it. I could wrap those console.logs and an if and check for certain tags so that I'm not getting too much noise. But I know that we don't have too much here. So we're going to scroll up and eventually, okay, gateway role. I should have put some new lines in, shouldn't I? Where are you? Oh, I'm being really silly. This worked because I added the remap function. Let's comment this back out. I'll run it one more time. We want the error, we want to see our type, and then we'll see the properties. So do we have the error? No. Well, here we go. This is what we need. So we have the found type for AWS API Gateway REST API. That almost matches our error. It's close enough. We can see the properties here. We have the endpoint configuration, which has types of regional, and we have the name, which is the Lambda REST API endpoint. We can see that types is an array, whereas in our native, in our classic provider, we need to just have a single type, and we break that down. Okay. So let's bring this back in. We'll turn off the noisy debug output. We'll run a preview one more time. We don't need the logs, and this should just give us a happy preview that just works. Awesome. It's going to create 36 resources. I'm not going to run it. It does take a bit of time, but I'll show you one more example and we'll wrap this session up. So this works with CD ECS. There we go. This works with many of these patterns and resources ones. So I've got one more. Nothing on my VS Code is working today. So here we're pulling in the ECS patterns guide, or construct. We create a VPC, we have a cluster, and then we're saying that we want a network load balanced Fargate service. There's a whole bunch of stuff that happens here. We don't need to worry about it. We just provide a little bit of config, and then we have a service with a scaling configuration like so. And then we consume this just like we would anything else. So in order to run this, I need to modify my pulumi.yaml. And I'm just changing the entry point using the main configuration to be ecs.ts. And now when I run Pulumi preview, we will see lots and lots of things. And now it's telling us that we have an AWS native application, auto-scaling, scaling policy not found. Again, we could turn on that debug logging, come into our adapter, and we'd see that this is actually called, again, something different in the classic provider, AWS app autoscaling.policy. Expand out all the props that's required, come back to here, run our preview, and that will work. So what we're seeing here is that within Pulumi programs, we can use AWS CDK constructs. Oh, I'm not expanding the props right, but I'm not worried about that. We did see that all the resources are here. But what we can see here with Pulumi programs, we can pull in CDK lib. We can use CDK constructs, even down to the L3 advanced patterns ones that do a whole bunch of stuff for you and expose a nice simple API. You do have to get familiar with writing the remap functions. Do it once or twice, use console log as much as possible, and from there you'll be pretty happy. All you need to do is override, or at least pass in and augment the options to the super constructor with the remapping logic, and your Pulumi program will just work. All right. Thank you for tuning in. I hope that this is interesting. I hope that using CDK within Pulumi is something that you want to try. What I would encourage you to do is to, one, subscribe to this channel, give us a comment, like this video, any of the above, and stay in touch. I'm on Twitter at Raw Code. Happy to help you if you have any issues. And we'll be back next week with more modern infrastructure. So until then, have a great day, and I'll see you soon. Thanks.